Now, actually, I am going to perform two derivations. Okay, that is work done by gravity and work done by frictional force on dragging an object up the hill. Okay, you please write down that two part is very important. Actually, it will give you some interesting insights. Okay, so you please write down work done by gravity and friction while dragging an object up the hill. So what is the actually situation? First, let me understand, huh? So this is a just a rough and tough that on slope of that hill, okay? And height of the hill is say that is h, okay? And this is L, okay? Say this point is A, and from A to B, what I am doing, I am taking an object, okay, dragging it, okay, dragging, and surface has friction, frictional coefficient is mu, okay. So now actually I'll calculate that work done by gravity and work done by friction only, okay, and you are going to get two interesting that an answer here, okay. It will be really interesting, and after that, after discussing work energy theorem, I will calculate work done by the man also. What is the work done by the man, and what is the work done by the net force? Okay, all these things we are going to calculate. But now I'm interested to calculate only work done by two forces. One is gravity, another is friction. Okay, see. Say I am taking a small displacement here. Okay, small displacement. This one here to here. Let us have a small displacement dr here, okay? So let us draw this magnified view of this dr, okay? So dr is very small, huh? But I'm giving a magnified view only. And at this point, say slope is theta degree. And you should understand that slope is varying, okay? For different points, slope is different. So let us draw a perpendicular here. So let us have, this is dy and this is dx, okay? It means dr has the two components, okay? dy and dx. So here I can say easily dx is nothing but dr cos theta, okay? So and dy is nothing but dr sin theta, okay? Well, but now you see on dragging the object, okay, from here to the dr displacement, okay? So what is the work done by the gravity? So gravitational force is nothing but mg only. So work done by the gravity is nothing but integration of force by gravity and displacement a dot b, and angle will be cos, because this is 90 degree and it is theta, okay? So it will be 90 plus theta, okay? So that gravitational force is mg only, okay? And dr and cos 90 plus theta is minus sin theta, okay? So if you take the minus sign out, mg constant, so it is also out. So it is becoming dr sin theta only. So that dr sin theta is nothing but dy only, na? So it is minus mg integration of dy. So the interesting part is that gravitational force is actually just depends upon the vertical shift, okay? So because dy is only the vertical shift, na? So from A to B, if we integrate it, I am going to get h only, okay? So it means work done by gravity is minus mgh. How it is going, it does not matter. Just final answer is how much height it covered, okay? So answer is minus mgh only. That is interesting, okay? It is, you can say that it is slope independent, okay? Sometimes slope will be more, sometimes less, but gravitational work depends upon only the vertical shift. If it goes high, work done by gravity will be negative. If it falls down, comes down, So gravitational force work done will be positive. Okay, that time it will be positive. But as it is going up, it means it is going against gravity, so work done is negative. And formula also says like that only. So you please copy all these things because now I am going to do that work done by the friction. Please copy all these things. Okay, now let me calculate the work done by frictional force. Okay. So again, work done by frictional force is what? This is nothing but integration of F dr, small f means frictional force, dr and cos 180 degree because you see the object is going up the hill and friction is just opposite to the displacement. So it will be automatically cos 180 degree only. Okay. So it will be minus cos 180 degree is minus. And you know that frictional force is mu into normal reaction only. Okay, mu into normal reaction. And already you understand that if you draw the free body diagram, so mg is vertically downward, and this part will be mg cos theta, if it is theta, okay, and this part will, and this is normal, okay. So it means normal is equal to mg cos theta only. So mu mg cos theta and dr, okay. Cos 180 is minus 1, already I have taken out. So now you see, again you want getting some interesting result here. Minus mu mg, okay, integration of dr cos theta. So you see dr cos theta is nothing but dx only, okay. So you can say that work done by the friction actually finally it depends upon the horizontal shift only, okay. Gravitational, it is depends upon the vertical shift. But in case of friction, it is integration of dx. Integration of dx is nothing but L only, na? Length horizontally. So it doesn't depend upon the slope, okay. So it is a special result. You should learn it, okay. So work done by the friction equal to minus mu mgl, okay. So this is the final result. So you should from now onwards, you should please learn it, okay. Work done by friction depends upon that horizontal shift only, and work done by gravity depends upon the vertical shift only. Okay, please write all these things, and we'll just take use of it in the forthcoming chapters. You see, integration of FDR is nothing but the that area under the F and R graph. Okay, means force and displacement graph's area gives you the that one only, na, work done. So let us do one or two questions from that graph only. So you please write down work done by variable force. Okay, say we are having one graph. Okay, force versus displacement. So this is the graph. Okay, so force and displacement. Okay, the graph is this. Okay, initially it was at R1 and finally it is going up to R2. Yeah, RF. Okay, this is the force axis. So actually the area under the graph, na, it will give you the total work done only. Okay, so total work done is nothing but integration of FDS or FDR. Okay, anything you can write. But remember, it is a vector quantity. Okay, area is a vector quantity. If the area is in the positive quadrant, so it will be positive. If it is in the negative quadrant, it will be negative. Okay. So you please write down all these things. Area under the graph is equal to under the force displacement graph is equal to work done. Okay. Sometimes directly a question from graph comes. Na? We do not need require to integrate it. Okay. Directly we can take you can calculate the area. If it is a trapezium, use the formula for trapezium. If it is a circle, use the area for circle, triangle, to use the formula for triangle. Okay. And it is also very interesting. Say here actually in the figure you can see area 1 is positive, okay? Area 2 is negative, okay? So if you are asked to calculate the work done from say from very beginning to this point, okay? So you have to just calculate A1 minus A2, okay? Not A1 plus A2. Because second area is negative here, okay? That is very important. Second area is negative here. Please let me know once it is copied, okay? Okay, in the question, it is said that force F on a particle moving in a straight line varies with distance as shown in the figure. The work done on the particle during the displacement of 12 meter. Okay. So here the displacement is from 0 to 12 meter. Okay. So, but I have to calculate the area of this portion only. Okay. Why this is so? Because you see, before that actually force was 0. Remember, for work done now, either both force and displacement both must be there actually. So from 0 to 3, force is not there, but the particle is displacing. It may be, without force also a particle can displace. See, in space, all the particles are keep on moving only, but net force is 0 only, okay? So for displacement, actually force is not required. Force is required for acceleration only. Anyway, so here we have to calculate the area of that part only. Okay, so this is simply a trapezium. If you say it is this is parallel side. Okay, and this is the perpendicular distance, means separation. Okay, so work done equal to what? Work done equal to area of the trapezium only. Okay, so area of the trapezium, half of the sum of the parallel sides. Sum of the parallel side. You see, this side, length of this side is 4 only, na? Because this point is 7, this point is 3. So 7 minus 3 is 4, no? So 4 plus. And length of this side, this is 12, this is 3. So 12 minus 3 is 9, okay? The length is 9. Into separation between the two lines. So this is the separation. It is 2 only, okay? Already given. So this is the answer, nothing else. Okay, this will be the 13 plus 13. All are in SI, so you can directly write it as Joule. So work done is 13 Joule only. Okay, so here the beauty of the question is actually these portions we have to remove, because force is not there. That is why actually the question is a little bit stunning. Okay, so please copy all these things and let me know. See. Here actually you see work done by non-conservative force. All actually say take an example of friction only. Okay, so friction is a good example of non-conservative force. Okay, say what I'm saying is that say this is a horizontal table. Okay, it has say 4 pillars. Okay, now what I do here, one object. Okay, one object of mass m. I just take this mass slowly along this circle. Okay, it is a circle. Okay, of radius say r. Okay, so now question is what is that one work done by the friction. Okay, say surface coefficient of friction is mu. Is the answer is 0? Because you see here the displacement will be 0, na? Here to here the displacement will be what? 0 only, na? It is completing one loop only. Now my question is work done by friction will be 0? No, no, not at all. It is not 0. Actually, in such situation, for non-conservative force, we have to calculate the distance, not the displacement. So you can, one way you can say that in the formula F dot dr, okay, if it is this conservative force like gravity, spring force, gravitational force, like that, okay, then it is displacement, okay. But if it is non-conservative force, then it is integration of dr is nothing but the total distance only, okay. So we have to calculate that way only. You see, let me explain it why. Say in this situation, I need to calculate work done by frictional force. Calculate the work done by frictional force. So you see, if you draw the free diagram, mg is downward, normal force is upward. If you apply a force rightward, then friction will be leftward, okay? But as it is dragging, so frictional force will be obviously maximum frictional force only, okay? And maximum frictional force, it means F max is always equal to mu into n and always equal to mu into mg, okay? So now you see, for a small path, okay, say from here to here, the displacement is along this, okay? But friction is along this opposite direction. So dW will be what? dW will be frictional force, that is mu n. Displacement is dx, or you can say dr also, no problem. Dr cos 180 degree. It means it is -1 because both are in opposite direction. So it is minus mu n is nothing but that one, na? N is nothing but mg, and it is nothing but dr magnitude only, na? Because you know that this is nothing but magnitude, na? And cos 180 degree. And for that only I have put that minus sign. So I have written cos 180 degree. So I remove minus. So in the second step, I have written minus mu mg because mu is constant and is mg only. And that dr is magnitude only. So magnitude of displacement. Now I have to integrate it. So magnitude of displacement will be nothing but the total distance only. It is not displacement. Okay. Integration of magnitude of displacement is always distance, not displacement. So it is equal to what? Minus mu mg total distance. So it will be 2 pi r. R is that one. Okay. So this is the answer actually. If you integrate it, you are going to get the total work done only. Okay. So it means here the answer is not 0. That is very important. Okay. If you go in a rectangular loop, okay, say it is B, it is L. So the answer will be what? Work done by friction will be minus mu mg B plus L plus P plus L, means 2 times L plus B. Okay. If you go in a equilateral triangle, L plus L plus L, 3L. Okay. This part will be distance only. This part will be distance. Have you understood it? For this type of situation, okay, for non-conservative force, But for conservative force, actually, what happens? Actually, why this is so? Because you see, every moment the angle is 180, cos 180 degree. You see, when you go in this direction, so friction will be opposite direction. So cos 180 degree. When you go in this direction, the friction will be opposite direction, cos 180 degree. When you go in this direction, friction will be opposite direction, cos 180 degree. So everywhere it is cos 180 degree. And this is nothing but the magnitude only. So integration of the magnitude of dr will give you the distance only. Okay. But it is not happening in case of the gravitational force, spring force, and all other conservative forces. Do you understand it? Please copy it, all these things. Now you see, you know some examples of conservative force, or you know some examples of non-conservative force. Okay. Conservative, that one examples of conservative force is what? Say gravitational force, spring force, magnetic force, electrostatic force, etc., etc. Example of non-conservative force is what? Say frictional force, viscous force, nuclear force. Okay, these are some examples. But if I give you some mathematical expression, say, so say F equal to 2I cap plus 3J cap, okay? Whether it is a conservative force or non-conservative force. If I give you 2I x 3YJ cap, whether it is an example of conservative or non-conservative, okay? So we can know from, that we have some rules, okay, to understand. So let me discuss it, okay? You please write down F force F equal to Fxi cap Fyj cap is said to be conservative only if there is a certain condition, only if differentiation of fx with respect to y, but remember it is a partial differentiation, okay? It is also called dou fx dou y. If differentiation of fx with respect to y and differentiation of fy with respect to x is equal, okay? Otherwise, it is non-conservative. Otherwise, it is non-conservative. Say example I am taking, okay? Say F equal to 2I cap plus 3J cap, okay? So whether it is a conservative or non-conservative, you see. Here actually this is Fx and this is Fy. So you see D, but don't write D, okay? You please write dou, okay? Dou means partial differentiation. So dou y of 2, it is equal to 0 because it is a constant. Dou z of 3, dou xx, so it is also 0. It means both are equal, so it is a conservative force, okay? Say example number 2. Say F equal to 2xi cap plus 3, say y square j cap, okay? So here fx is this, fy is this. So if I differentiate dou y 2x, remember, as it is a partial differentiation, so differentiation of x with respect to y 0 ही होगा. Okay, it will be 0 only. So dou x of 3y square. So it will also be 0 because it is differentiating of y, differentiation of y with respect to x. So both are equal, so it is also a conservative force on. Okay. So if I take another example, say F equal to say 2y I cap plus 3x square j cap, okay? Whether it is conservative or not, let me check it. So this is fx. Remember, this I coefficient is always fx. So dou y of fx, 2y. So it will be 2 only. Yes or no? 2 is constant, then dou y by dou y. And dou x of 3x square. So it will be what? 6x. So remember, this is not equal. You see? First one is 2, second one is 6x. They are not equal. If they were equal, then it will be also a conservative force only. Okay, I can make it equal. No need to worry about it. If I change this a little bit, it can be made equal. But as question is already given, so they are not equal. So it means it is non-conservative force. So this is the example. This is mathematical expression of non-conservative force. Okay, non-conservative force. You please write down all these things.